So hello guys, welcome back to our channel. So in this live we are going to solve the today's LeetCode problem. So today's LeetCode problem is 1758. The minimum changes to make alternating binary string. So let us see the problem here. So here's the question. So you have a binary string. So it will only have just zeros and ones, and you want to make it alternating like 0 1 0 1 0 1 or 1 0 1 0 like that. So the meaning is no two adjacent characters are same. Like it should be 0 1 0 1 or 1 0 1 0. So how many characters do you need to flip? Have to give us the output. Okay. So a string is called alternating if two adjacent characters are equal. So for example, they have given the string 0 1 0. It is alternating, and 0 1 0 0 is not alternating because there are two continuous same characters. So it should be different. So we have to return the minimum number of operations needed to make the string alternating. So here's some examples here. So they have given that 0 1 0 0. So it is a string, and the output they have given is 1 because if we change the last 0, there is 0 1 and 0 1. So that is the minimum character we can change, and it should be alternating. So for 1 0, it is already alternating, so we don't need to change any characters, so that is 0. And the next example, we can change 0 1 0 1 like that. We can change these two characters to 0, or we can change these two characters like 1 0 1 0. Both are possible, like 0 1 0 1 or 1 0 1 0. Both will have minimum of two characters. So we can simply give true as the output. So here you are given a string consisting of characters zeros and 1. So the in one operation you can change 0 to 1 or otherwise 1 to 0. So a string is called alternating if two adjacent characters are equal. So what does alternate means? So let us see here, like any two adjacent must be different. 0 1 0 1 0 like that, it should be alternating. So what are not alternating means like this: 1 0 0 1 1 0. So 1 1 1, those numbers are not alternating. So as you can see here, there should be two possibilities of pattern. So if we start from 0, it will be like 0 1 0 1 0 1 like that. So if we starts from 1, so it should be 1 0 1 0 1 0. So there are two patterns. One is like this, another one is like this. So there are two patterns mainly. So after that, using these two patterns, we are going to count the number of operations we can do. So first we'll check for this pattern with the size of this string, and check for this pattern with the size of the string. So if we want and calculate two changes, and which one is minimum, you have to give it as the output. So now they have given these three examples. So first one is 0 1 0 0. So let me take here, it starts from 0, the length is 4. So here it starts from 0, so 0 1, the size is 4, so it should be 0 1 and 0 1. So the size is 4. So if I want to change it in 1 0 1 0, these are the two possible outcomes. So now I'll calculate with the current string, that is 0 1 0 0. So first check with the first string. So if we check it, 0 0 same, 1 1 same, 0 0 same, 1 0, different, so 1 will be added here. So after that 1 0 1 0. So for 1 0 1 0, see here, that is, this is the thing. So for here it's also 0 1 double 0. So here 0 and 1 changing, so 1. So after that the second value 0 and 1, so it changes, it will become 2. So after that, as you can see, 1 and 0 changes, it has become 3, and 0 and 0 it is same. So 1 and 3 are the two possibilities for the string. So now the minimum value in these two values is 1. So is simply put 1 as the output. So here 1 is the output. So we have to calculate for both two patterns, and we can simply give the minimum number as the output. So let's see the core insight of this problem. So this section is where the magical happens, that is, I want you to focus. So we just established that there are only two valid targets. One is starts from 0, one is starts from 1. There are only two possibilities. So let me name it as pattern A, that starts with 0, and pattern B, that is starting with 1. So let's call the number of positions where differs from the pattern A as counting A. So now here's the key question. If we know the counting A, how many positions differ from pattern A do we need to separately count for the pattern B? So the answer is no, we don't need, and here's why. So first let me take these two patterns. So pattern A and pattern B. So the first one is starts from 0, 1, 0, 1, 0, 1, and etc. The second one is starts from 1 0, 1 0, 1 0, and so on. So these are the two patterns. So every position, so if my string of I, that is the current index value, so the first let's see this value. So the pattern A and the pattern B. So pattern A is complement of pattern B, because if it is 0 it will become 1, if it is 1 it will become 0. 1 and 0, 1 and 0 both are alternative. So at every position the index value I, so the string of I, that means the current index, matches with pattern A will not match with pattern B. Okay, if it is matches with this value, it will not match with this value. So the pattern B, if it is matches with pattern B, it will not matches with pattern A. If it is matches with pattern A, it will not match with the pattern B. So this means every position is either a mismatch of A or the mismatch of B. So we just need to calculate any one and differentiate with it. So for example, I can say that the difference in count A and the difference in count B, if I sum both of the difference, I'll get the exact count. Okay. So now this is the n is nothing but the total length of the string. So now if I want to calculate the count B, I just need to subtract n minus count A. First I calculate count A, and if I want to calculate the count B, I just subtract from count A with the size of the string. So we only need to count the mismatches for any one of the pattern. The other is automatically n minus that count. So then we can find the minimum value with these two values. So why does this work intuitively? So think of it in this way. So every character you change fixes the next value. Okay, so it is like an alignment of pattern A that is break with the pattern B. So on every character that already matches with pattern A or already mismatches with the pattern B. So the total number of fixes needed across both patterns will be always adds upon to n. So minimizing one automatically maximizes the other. So we just want to smaller the value of this. So this is a greatly insight. So now let us write the program. So let me increase the size. So here first we calculate the string. So I'll name it n and the size is s dot size or s dot length for string. So I'll use size here. So first we will see the method they have given. So the function, so they have given the return value is integer data type. So we are returning a count of operation. So with the input is string passed by the value as the parameter here. So since the v n never will be modified. So this is fine. So in competitive settings, you could pass by the constant reference as the large inputs, but for n up to 10,000 it doesn't matter. We can simply pass the directs. So now we will get the link through this line, that is n equals string dot size. So we are storing the string length in the value, the variable n. So we will use it more than once. So that time I am storing in this variable. So once for the loop and once for the computing of n minus count minus a. So always catch your size rather than calling the s dot size multiple times, especially inside the loop. So make sure to store it in some more variable. So after that, for counting the pattern A, so I will declare one variable count A. So it is an integer data type and I initialize it with 0. So after that, a for loop. So this for loop is for iterating through the string with every index. So I is 0 because string is 0 indexed, I less than n and I plus plus. So this is the familiar pattern we will be used most of the time. So after that, so this is the next line is going to be the entire logic of this function. So we are going to compare, and this is the most important line in this program. So I can say that the pattern A, look here, we have said the pattern A starts from 0. So at even indexes, like it starts from 0, so I will name it as even indexes as start. So for even indexes, it is 0 and odd indexes, it is 1. Okay, 0, 1, 2, 3, 4. So as you can see, even indices is 0, odd indices is 1. So here I can use character indexing. So for that, I'll check that first here my current character is, so what I am going to check is if it is not equals to, that means it is changes, so that time I'll change the value. So for that I'll use the character 0. So I'll add with the value of the current index modulus. So if it is even index, it will add 0. So if it is odd index, it will add 1. So we can simply check if both of them are equal or not. So after that, if it is changes, I will increment the count by 1. So now this is the character 0. So it plus another 0. So it will not change anything. So for the character ASCII value of the character 0 is 48. So for all the even indices, it will be 48. So that is nothing but 0. Okay. So for all the even indices, it will become 1. So 48 plus 1 will become 49. So the value of 49 is nothing but the character 1. So 0, 1, 0, 1, 0, 1 and so on. So the expected character at the position of index first is 0, that is even index, and for the odd index it is 1. Okay. So now this, for this line, that is I modulus 2. So this is the index that is gives us 0 and 1 for the indexing value. So it will give the value of 0 for all the even indices, and it will give the value of 1 for all the even indices. Okay. So that's why we are using this. So it will give us the exact expected character of the pattern at A, and it is compact. So now we'll just increment the counter. So count A will be incremented by 1. So each mismatch between the string S and the pattern A increments the count A by 1. So after the loop, the count A holds the total number of changes needed to transform this pattern A. So now I'll create one more variable. So count B is n minus count A. Or else you can directly use it in the return function. So I'm using here. So I'll store it in variable. So after that, we have to return the value. So return I don't need this. So minimum of, I'm using an inbuilt function. It will return the minimum value of both of them. So count A, comma count B. So there are two values. It will return the minimum value of it. So let us run this. So it is passing. So here I can simply change the value. So I don't need to declare this variable. It is not even necessary. You can simply change this line with n minus count A here itself. So let us dry run with this example input output and let us know how it's working. So see here, so the first thing is 0, 1, 0, 0. So this is the string. So the current value of I is 0. So S of 0 is 0. Okay, what expected is here it starts from 0. So it is 0 equals to 0. So it is matches. So the count A is 0. So after that, the I value will become 1. So the string of 1 is 1 here. So 1. So what expected here is 1. So the count A is still 0. So the I value will become 2. So S of 2 will become 0 here. So they have given 0 here. So this value. So now 0 equals to 0 is true. That is, the count will not be incremented here. So I value will become 3. So S of 3. So now the value is 0 here they have given, but the expected what we have to get is 1, because 0, 1, 0, 1. So 1 is expected here, but we have got 0 as the input. So now we have to change it because the value is 0 is not equals to 1. So if it is not equals to 1, the count value will be incremented by 1, it will be 1. So after that, so the n is nothing but 4. So we have to check minimum of 1, comma 4 minus 1, that is 3. So the minimum value of 1 and 3 is 1. So we will get the output as 1 here. So let us check for the second input, that is 1, 0. So the n is 2. So I value will become 0. So the s of 0 is, they have given 1 here. So they have given 1 and 0 here. So now we need to check that. So the expected pattern should be starts from 0, 0, 1, 0, 1 like that. So what we have got 1 here. So 1 not equals to 0. So now the count will become 1. So after that it is 1. The string of index 1 is nothing but 0. So 0 not equals to the value 1. So 0, 1 is the expected value of pattern A. So the count of A will become 2. So now we have to check for the minimum value, that is count A 2 and the length 2 minus 2. So now the minimum value of 2 and 0 is 0. So 0 is the output because it is already alternating. So we just need to check with the one pattern and subtract with this value and print the output. So let us check for the third n. 1, 1, 1, 1. So now the n is 4, size 0, s of 0 is 1 they have given, but we have to check for 0. So 1 is not equals to 0. So 1 here, 1 is not equals to 0. So now the count of A pattern will be 1. So after that I value is 1 and s of 1 they have given is 1 and we have to check for 1. So both are same. So count will not increment, count will be still 1. So I value is 2 and s of 2 is 1 they have given. So 1, but we need to check for 0, 1, 0. So 1 and 0 are alternating. So both are not equals value. So the count A will incremented by 1 again. So it will become 2. So now I value will become 3. The string of 3. The value is still 1. So 1. We still want 1 here. So the count A will be will not increment because both of the value are same. So it still remains 2. So now we have to check for minimum of 2 and the n minus 2, that is 4 minus 2. So we will get minimum of 2 and 2. So both are same. We can simply return 2. So 2 was the output. So this is how this code is being executed in the background. So after that it is expected this value and run this value. So let us see the complexity of this problem. So we run a single loop. So this is a single loop here over the all n characters inside the loop. So every operation is we go off 1 and a modulo character comparison and increment. So there are no nested loops inside it, just a single conditional statement here, and there is also no recursion, no sorting. So the total time complexity is n. with the n up to 10,000 characters, and this is about the simple operations, so it finishes in the microseconds. So the time complexity is big O of n. Okay, because we are iterating through a single loop for the every values. So the next one is space complexity. So for space complexity, we use only two integer variables here, that is for storing the n and storing the count. So no other values. Previously I have used for n count b, but I have removed that and directly using in the return statement. So there will be no extra space other than two integer variables. So n and count a. So there is no arrays here, no strings there, extra strings, no hash maps, and no extra data structures. So the space usage is constant regardless of the input size. So now we can simply say the space is not changing. There is nothing but big O of 1. So for a easy problem, this is the best you can possibly do. That is in the linear time and the constant space and the clean code. So let us see the common mistakes people would do. So the most common beginner approach is to construct pattern A as a string and construct pattern B as a string and then compare each characters. So this works, but we have uses big O of n, but if you use that, the space complexity will be increased as well as the time complexity will also be increased. So that is the worst case. So after that, counting mismatch for the both patterns. So many people write two separate loops. So one for counting mismatched element and one for counting the matching element. So that is also one of the worst case here because it will increment the time complexity. So we just need to calculate using this formula. So we have already found that if we add count A plus count B, we will get the total n of the second. So we can simply subtract each one from another to get the value. And the most beginner mistake is confusing with the 0 index to the 1 index. So 0 indexing is nothing but in strings and arrays, it would be 0 index. As you can see for this line, the 0 character plus I modulus 2. So we are choosing the 1 pattern, and in this even means it is odd element, that means in the first character it is odd, but even though it is 0 index, it would become even indexed. So that's for this problem. So let us move on to next problem. So before that, let us submit this problem and check the output. So now it is being completed. So here the runtime is 0 milliseconds and it beats almost every problem. So let us move on to next question, that is the longest substring without the repeating characters in the array or in the string. So as you can see here, we have to find the substring within a string. Okay, so they have given the input as a string, and after that the length of the, we have to find the longest length of the substring without any duplicate characters. So this problem is LeetCode number 3. So this is a medium level of problem, and this is also called used in questions in Google interviews as well, and most of the FAANG companies as well. So now let us see the basic overview of this problem with the test cases as well. After that, we can solve this problem with the basic intuition and how to approach this problem. So before anything else, we need to be clear on one thing. So this problem asks for a substring, not a subsequence. So these are completely different things. So a substring is continuous string like ABC. So all of them are continuous string. Okay. So it is uninterrupted portion of the string. So every character in a substring sits right next to its neighbor. So ABC, both of them are neighbors. I can't simply take this A, and this B. Okay, it have to be in the continuous of the string. So that is called a substring. So if it is a subsequence, we can remove and insert these characters. So yes, subsequence can skip characters. Like for example, I can A, C, and B. So it is a subsequence but not a substring. So LeetCode even calls this out explicitly in some of the examples. So now let us see these examples. So they have given ABC, ABC, BB. So ABC, ABC, BB. So this is a substring. So we have to write all the substrings here with the largest thing with unique character. I can say A is one substring, B is one substring, C is also one substring, and AB and BC, and as you can see there is CA and CB, CA, CB, but all of them have to be unique. Okay, so now AB is there, again BC is there, and CB is also there, and CA also there. So now each one character is completed, two characters completed, now three characters. So A, B, C. So after that B, C, A and C, A, B, and another ABC is there. So it is still already here, and BC, BCB is not there, and CB is also not there. So these are the possible substrings with the unique character. Okay, so here first I'll make the indexes here. So let me give some space. So 0, 1, 2, 3, 4, 5, 6, 7. So these are the indexes value. So the maximum length we can get is 3. So the output is also 3. Okay. So every character is be the moment we try to extend the past first characters. So we hit a duplicate. So the longest valid substring is just A, B, C, A, B, B, C. These are the possibilities. The longest is these three, and the all size are same. So that is 3. So now let us see for the next problem. The next example, that is B, 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 B. So the 5 characters. So the substring is B. Because this is the only possibility substring here. So every character is B. So the moment we try to extend this, the first character or the next character would be a duplicate character. So the longest value substring is just B, and the length is simply 1. So the next string. So for the next string, they have given the value, that is P, W, W, K, E, W. So this string. So in this string, I'll just show the index values. So the index is 0, 1, 2, 3, 4, 5. 6 characters here. So the substrings would be E, W, K, and E for single characters, and PW and WK, KE, and EW for 2 character of strings. So the next one is PWW is not possible, and WKE for the largest 3 strings up until now, and KEW. Okay, WKE or KEW. So these are the maximum size we will get from this string. So the size is 3. So the maximum size is 3. The answer is WKE with the length of 3. So notice that the answer must be a substring. So if we take like that, for example, PWKE, with skipping this W inside middle of that, it will be a subsequence and not a substring. The LeetCode is also mentioned here. So look for it and let us see the constraints here. So the constraint is the length should be, it can be 0 and 5 to the 10 power of 4. The string length could be 0 as well as 5 to the 10 power of 4, and it can contain English letters, digits, symbols and some more spaces. So now it can contain around 50,000 characters. So this rules out any O of n square solution, that is 2.5 billion operations in the worst case. So we need to run it at the maximum of big O of n. So that means we have to complete it within the same string. So if we use brute force approach for using nested loops, it would be around big O of n squared or n cube. So the naive approach is to check every possible substring and verify it has all the unique characters, and for the string n, so that time it will be n multiplied by n plus 1 by 2 substrings. So and checking each one takes O of n time, and the worst case would be big O of n power 3, so that is n cube. So that is the worst case for this problem if you go on to a brute force approach. So the key observation we got here is we were scanning the string from left to right and we'll hit the character that is already in the current window. We don't need to start completely over. So we are going to use sliding window approach here. So think of it like a sliding frame. So we push the right edge forward as long as everything inside is unique. So the moment a duplicate appears, we pull the left edge forward until the duplicate is gone. So every step we record is the window size. So this is the sliding window technique. 2 pointers left and right defining a window. So the window only moves forward. So the total movement of both pointers is at most 2n. So the entire algorithm is big O of n. So we can also use hash map. So why not we can use a hash set. So a hash set tells us if a character is in the window. But when we find a duplicate, we need to know where the window it is. So we can jump left pointer directly as the pointer instead of crawling forward one step at a time. So hash map is from character and its two most recent index give us the big O of n. So when we see a character as the index, so that is already in the map, who last seen index inside the current window, we jump into directly to the last seen index. So let us see the algorithm we are going to approach here is, the first step is left window initializer and the maximum length that the sliding window can hold. So both will be initialized with 0. So after that a empty hash map that stores each and every characters with the most recent index. So we have to iterate the right character from, we'll declare another pointer for a right. So the right pointer will be starts from 0 to n minus 1. So the n minus 1 is nothing but for the last character. So we will check if the s of right, that means the current pointer, the right sliding window is already in the map. So if the current character is already in the map, and if it is not, we have to store it in the map and check for the value. So if it is greater than or equals to the left value. So meaning that it is inside the current window. So if yes, we have to move the left to the maximum of the map of s right plus 1. So that means we will jump out of this duplicate value and get to the next value. So after that we have to update the map. So if we update the map, that time the previous last position, that means the character, will be stored in the map, and after doing that we have to update the maximum length. So the maximum length is the maximum of the current maximum length with the value of right minus left plus 1. So this is how we will update the maximum length, and finally we will return the maximum length. So this maximum length is nothing but the longest string here. So now let us move on to the problem approach. So first we will see the problem that they have given this method with the string input, and they want integer as the output, that is nothing but the longest length of the Unix substring. So first we'll declare one unordered map. So it will store one character in the int. So the key is the character and value is the most recent index at which the character was seen. So for that, so I am using an unordered map. So unordered, this is the declaration of the unordered map in C++. So after that, character and int. So this is the key and this is the value, that is the last seen. So I am naming it as the last seen index value. So why we are using unordered map over a normal map? So a regular map uses red black tree that gives big O of login for every operation, but in unordered map it is a hash table, that is the average case is big O of 1. So for this problem we want big O of 1, so always we will prefer unordered map when the key ordering is does not matter. So now I will declare one more variable, that is left is 0. So the left is the left boundary of the current sliding window. So it starts as the index 0 and the beginning of the string. So it will be only ever move forward and never move backward. So this single direction movement is what it makes the algorithm big O of n. So now the result variable that we have to return it. So I am naming it as maximum length with the size of initialize with 0 because we will not return the string yet. So the maximum length tracks the length of the longest valid window we have seen so far. So it starts at 0. We haven't seen anything yet. So we update it very iteration. So next one is the main loop. So for that, so it is the right side. So in the right value is 0 and the right is less than the size of the string, that is string dot size, and right incremented by 1 for the every loop. Okay. So now we will store the current character in a variable. Char, I am naming it as C. So I'll store s of right here. So now I have stored the current character. So we extract the character with the current right pointer in a local variable C, and this avoids indexing into S multiple times and makes the code cleaner and slightly faster. So now we have to check that. Now the main part of this program, that is the first condition, that is if my map, that is last seen I'll use count method. So within it, I have to use the character as the value. And my last scene, within it, we'll give the character key. So after giving it, I check that if it is greater than or equals to the left value. Okay. So this is the condition. Let me explain it once again. So this is the first part of this condition, and this is the second part of this condition. So let us see the first part. So the count method on unordered map returns 1. Okay, it will return 1 if the key is exists. So it will check that have we seen this character before. So the next part, this is the second concept. We are using this part for checking we have already seen it or not, and this part. So even if we have seen the character before, it might be outside the current window. So to the left of our left pointer. Okay. So the left pointer, if it is outside the left pointer, that means it is outside the window. It doesn't matter. So we only care if the previous occurrences is inside the current character. So this left is nothing but the range over it. So if it is greater than that, it will be outside it. So both condition must be true together. So if we have a duplicate inside the our window. So if it is inside, we move the left character by 1. So if it is true, we have to move the left character by 1. So left is last seen character of the current character plus 1. Okay. So here we have checked the value, and this line, that is left equals last scene of character plus 1, we jump left directly to one past previous occurrences of the scene. So this eliminates the duplicate from the window in one step. So not by crawling forward one position at a time. So next we have to update the map. Okay. So now after doing this, we have to update the map. So by doing that, just come here and just the last scene of current character will become the right value. Okay, that is nothing but the current index. So after storing it, we have to check the maximum length with the current value. So the maximum length is maximum of this inbuilt function. So maximum length with the right minus left plus 1. So you may ask, what is this line? I can't understand like that. So now I explain it. So first we will see this line, that is updation. So whether or not we move left, we always update the map with the current position of C. So this ensures the last scene always holds the most recent index. Okay, we will always move this right pointer. So that time we have to store this current character and the index value in this map. So that's why we are doing this. So this line runs unconditionally outside the if block. So even if this condition is fails, this will still change the value inside the unordered map. So after that, we are updating the maximum length. So the current window span is the index left to index right. So it is nothing but the inclusive. So its length is the right, that is current value. Okay. So after that, it will be subtracted from left plus 1 because it is 0 index. So 0 plus 1 minus the right value. So we update the maximum left if this window is longer than anything we have seen before. So this also runs unconditionally every iteration because it is also outside the if condition. So even if we just move left forward, the new window might still be the longest so far. So these are the operations. After doing these operations, we have to return the maximum length. Outside this for loop, just return the maximum. Okay. So after processing every character, the max length holds the length of the longest substring without any repeating characters, and we return it. So let's do a dry run. Before that, we check for the sample test cases, 3 test cases here. So it is being accepted. So now let us see the dry run. So initially the write nothing but the iterating index is 0. So after that the current character holds the value of 8. So let us do for the first string. So A, and the last scene, that is this map, will have empty, that means it have no duplicates. So after that, just come here. So now we'll just add this last scene with the value of the character A, and the key value, this key value A and the pair is 0. So now the window is 0, 0, that is nothing but the character, that is the substring A. So the length of this is 1, that is nothing but the maximum length is currently 1. So after that, the next index, the right will be moved by 1. So the right value will be 1, and the current character is B. So the current character is B. So now we have already seen the value, that is this value will be stored. So we just store this value inside this map. So after storing it, we check if B is present in this map. No, it is not present in this map. So after that, we just store it here. So the last scene value will be A with the 0 index and B with the first index. So now the window size is, the left value is 0 and the right value will become 1. So the string is A and B. So the length will become 2. So pointer will be moved by 1. The second position of the string, right, is 2. So the current character of C is C. So after that, we have this map. So this is the map. So within it, the C is not there. So there is no value. So again, we just need to add this value with C is index 2, and after storing it, so the window will from 0 to, so the current string is A, B, C. So the maximum length is 3. So now it will move to the next index. The right value will become 3. So the current character C is, so A, B, C, after that another A. So that is A. So now we have to check with the A is present in this map, so it is present with the index of 0. So we'll check that 0 greater than or equals, that is the current value left of 0. So it is a duplicate value which is present inside the window. So now we will increment the left window by 1. So now the left will become 1. 0 plus 1, that is, so the last seen character of A will change to 3. So let us copy it and paste it. So within it, the A value will become 3 here and B is 1, and after that this value is 2, and the window size will become 1, 2, 3. So the size is 2. So 2 is less than 3. So still the maximum length will become 3. So after that the index 4. So the current character C is again B. So now the index B is present in the index 1. So we have to check the current index is greater than or equals to the left value, that is 1. So it is equals to 1. So that time the condition will become true. So left value will be incremented by 1. Left will become. So the right value will be also incremented. So window is 2 comma 4. The size is 2. So now the length would be 3 will be still greater. So 3 will be there. Still it will move on until it reaches the last value, because all other value other than ABC is presented here. So it will move and finally it will reach the last value. So the current character C will become B here, the last character. So it is previously in the previous index. So that means it should be present in 6. So 6 greater than or equals. The left value also be incremented to the value, that is 5. So it is greater than. So the left value will be incremented. So now if we take the window size 7 comma 7, because left will be incremented by 1. So left plus plus. So now this window is incremented by 1. So the last character would be the string, that is B. So the length is 1. So the maximum of 1 and 3 is still 3. So 3 would be the output, because the entire loop will stop and get out of the loop and return the maximum length. Okay, this is how it is being internally working. So we have do a dry run over it. So now let us see the complexity of it. So for the time complexity, so the right pointer visits each and every character once. So that is n iteration. The left pointers move only forward and it never exceeds the right. So each hashmap operation count, lookup, insert is also big O of n for the average of unordered map. So the total time complexity is, so let me write here. So the time complexity is big O of n, because we are running through a single for loop. We are not using any recursion anything, and also this map operation is also for the average case of big O of 1. So the time complexity is big O of n. So now the space complexity. So for this space complexity, it is big O of minimum size of n and m, because the hash map stores at most the entry of unique characters. So that time it will become because n and n will have the minimum value. So for the ASCII value of 128, the Unicode is larger, so the map at most value is minimum of n and m entries. So in this practice, the ASCII input is big O of 1. So since the at most value is 128, so it is big O of n in the worst case, and for entry purpose, big O of n space is if the character set is fixed unbounded, and big O of n for it is unbounded. So let us move on to the common mistakes people would do. They would not check for this window checking. There is last seen character is greater than equals to left value, and they will, instead of moving the left pointer here, what they would do is they will moving out of the bound, so that will make error and this will not be a correct answer. It will affect the output of the program. So after that, substring versus subsequence, they would misunderstood what is substring and subsequence and write a wrong code for it, and not handling for the empty strings here. So that's all for this video. So now let us submit it and check the output. So the code is being accepted for all 988 use cases. So this problem is solved with the algorithm of sliding window. So master this. So that time you can solve few more problems using this sliding window. So make sure to subscribe and get notified with the every live and every coding competition will post in this YouTube channel. So that's all for today's video. See you in the next slide.